Hey everyone, Mrs. Edstrom here. We are working on proportional. And what does it mean for something to be proportional? So we are on page 38 in your notebook. Go ahead and make sure you fill out today's date. And as I said, we're talking about proportional relationships between two either images or just two different things. So we'll see that in some of our word problems, everyone's favorite. Yay! So our essential question, what we are learning today, is how do I identify proportional relationships? And what that means is when we take two things that we are comparing, we want to know if the relationship between those two things, whether they're shapes, whether it's minutes versus miles or games versus time, we want to know when we're comparing those two things, is the relationship between them proportional? And so that's what we're going to start off with today. The first thing we're going to do is we have to define what does proportional mean? So for vocab, we are moving back to the back page of our notebook. And you have some of these filled out, but we're going to fill out proportional. So for example, you should have scale and scale factor corresponding. We're going to fill out proportional today. And so proportional, we can think of something that is proportional. It is similar. So sometimes you will hear shapes that are similar. If they are similar, they are proportional. We've been talking a lot about scaled, having a scaled image or scale drawing. If it is scaled, then it is also proportional. The main definition is every ratio within the situation is equivalent or the same. Equivalent. How do I spell that? There we go. Equivalent. Is equivalent. That means the same. So when we're writing those ratios, we've been writing them as fractions. We want them to be the same. So for example, if I have 5/1, that is equivalent to 10/2. That would be a proportional relationship if those were the two ratios within the situation. Whereas if I had something like 5/1 and 4/1, those are not equivalent. So this would not be proportional. It would not be proportional. This one would be proportional because the fractions are all equivalent. This one would not be proportional. So make sure you've got this definition here. We're looking at all the ratios or fractions within the situation are equivalent. So let's go ahead and take a look at our practice problems. So we're going back to page 38. And we're going to look at these rectangles. So when I'm looking at these rectangles, I'm going to say that the side lengths are 5 and 15. And then these side lengths over here, I'm actually going to say that this one is 14. And that I don't know what this one is. I'm going to say that this length right here is m. It's unknown. It's a variable. And what we're going to say is that when we know that these are proportional, when it's listed, these are proportional, or we know that they are scaled. We know that they are similar. So we're saying these are proportional. We're going to use sometimes what we call our proportional statement to be able to identify what this number should be. So remember, when finding our scale factor, we are writing our copy over original. So that means I am comparing my corresponding sides. I have 14/5. Since these are proportional, that means the ratios have to be equal. That means that whatever m is what goes on top, because that's our copy, over the original value of 15. So this right here, this is our proportional statement. We are saying it is proportional. Here's the statement saying that. This is how we can figure out what m is going to equal. We know, I'll use a different color to show this. Let's see, how about this color? 5 times what gives me 15? Yeah, 5 times 3 gives me 15. So remember, that means that whatever I multiply in the denominator, if this is going to be an equivalent fraction, I have to multiply the numerator by that as well. So that means I am going to multiply 14 times 3. So remember when we were breaking up numbers and doing our multiplication, trying to learn and practice to do it in our head, we were doing things like this. We were multiplying 10 times 3 and 4 times 3. I know that 10 times 3 is 30. 4 times 3 is what? It is 12, which means when I add those back together, I get what number? Yeah, 42. So that means that this m distance is 42. So this is just, I wanted to give you guys this example here. Sometimes you will be asked to identify missing side lengths, and you are told that they are scaled or they are proportional. And so that is when we can use what we know about proportional relationships in our definition, that every ratio within the situation is equivalent. That means we can write that equals. We can write those scale factors as being equal, and we can solve for what that numerator, or it could be in the denominator, but in this case, it's the numerator, what that equals. Now we want to go the other direction. We want to be given the fractions and be able to say, are they equal? Are they equivalent? Is the relationship proportional? So this number 1 here, notice there's a typo. So if you're working in the book or in the note packet with me, then you are changing that. If you are working on your own paper, then you're going to need to pause this video and make sure you write down the word problem, because it will not be any help for you in your notes if you don't have the word problem. So make sure you have the word problem written. Let's go ahead and read it. Jana runs a steady pace of 7 minutes per mile. That seems important. Is the relationship between the number of minutes she ran and the distance she ran proportional? So we can set our fraction up in either way. This one says minutes first. I'm going to put number of minutes on top of my fraction. So I'm going to say number of minutes over the distance. Or in this case, this was miles. So we're going to write our fractions and we're going to see if they're proportional. So 7 minutes per mile. That means if she runs 1 mile, how many minutes did she run for? Yeah, that's 7 right there. If she ran 2 miles, how many minutes did she run for? Well, if she's running 7 minutes per mile, that means for 2 miles, that's 2 groups of 7 for 14. We could keep going. 3 miles would be how many minutes? Yeah, 21 minutes. What we start to see is that this relationship, it's equivalent. This is 7 over 1. 14 over 2, it's the same as 7 over 1 if we divide both of these numbers by 2. It's the same as 21 over 3. They're all the same fraction if we reduce them. This is why it's really important to be reducing fractions. We're adding the same number of minutes per mile. Each mile we're adding the same number of minutes for every mile. And there's nothing else there. That is what makes this a proportional relationship. Let's try our last problem here. So again, if you're working on lined paper, you're going to need to take a moment and write down this word problem. We're going to get started by reading it here. So Anna has a new video game. It takes her 5 hours of playing the game to master level 1. After so much time, Anna understands the game a little bit better, and it only takes her 3 hours of playing the game to master level 2. Is the number of hours played and game level proportional? So we have our two things right here that we're comparing. Our hours played and game level. So hours played, game level. You could put the game level on top and the hours played on bottom. That part doesn't really matter too much. It's really up to you as long as you set up what you are doing. So I would always start off by labeling what your fractions are going to mean, and then we can look at our proportional statement and see if it's true. So it says 5 hours, game level 1. And it says hours played, so that means total hours played. So at the end of level 2, how many hours had she played for the whole time? 5 plus 3, right? We're talking about 5 hours played for the first level, and then to get to the end of the second level, she played 3 more hours. So how many hours is that total? Yeah, 8 hours. So she's played for 8 hours total to get through level 2. Are these equivalent? Does 5 over 1 equal 8 over 2? Couple of ways that we can do that. We can look at what we multiply by. So to go from 1 to 2, we're multiplying by 2. That means on top we should be multiplying by the same thing. 5 times 2 does not equal 8. So that means this is not going to be equivalent. The other way to solve this is to reduce this fraction. 8 over 2, we can divide both of those by 2 to get 4 over 1. And then it's a little bit easier to see that 4 over 1 does not equal 5 over 1. That is what makes this not proportional. Our ratios are not the same. The ratio for level 1 compared to the ratio for level 2 is not the same ratio. It's not the same fraction. That means that it is not proportional. We're adding a different amount of time for each level that she plays. So overall, when you are solving these problems, you are identifying the ratios, and then you are comparing the ratios to see if they are equivalent or not. If they are equivalent, it is proportional. If they are not equivalent, it is not proportional.